in this problem, I'm going to use the first derivative test to determine local extreme values of a function and find any absolute extrema, and then I'm going to support my answers with the graph. And this problem I'm going to take a little bit of extra time on because there's a lot of different graphing things that we can pull into it from pre-calculus and algebra 2 that they're just good to be able to kind of know how to apply them. So like always, I like to start with the domain of the function. And in this function here, I'm looking for denominators, radical signs with an even index, and logarithms. So don't ride lions. Don't ride, it's R-I-D-E, lions. That's my little acronym. And all I have is the radical sign with an even index. We know that that's a 2 when it's not written there. So, whoops, excuse me. So what I'm concerned about is make sure that the radicand, the part that's underneath the radical sign, is greater than or equal to 0. So I can just go 8 minus x squared must be greater than or equal to 0. Well, I think I'm going to start out by finding out where 8 minus x squared is actually equal to 0, because then I can work my way through the inequality. So I have negative x squared is equal to negative 8. So if I can multiply both sides by negative 1, and I get x squared is equal to 8. And if I take the square root of both sides, I get x is equal to plus or minus 2 radical 2. So that is where x is going to equal 0. And if I'm looking for, well, I need to make sure that this is greater than or equal to 0, then I know if I had a number line here, and here was 0, and I had, here is positive 2 radical 2, and here is negative 2 radical 2. I know that if I start getting into numbers like way out here, like say 5, 5 squared is 25, and if I go 8 minus 25, that's going to be a negative number. That's not going to fit in our domain. So what I know is that my domain is going to have to be between these two numbers. I'm going to square the x value, which is going to make it a positive number, so I'm not that concerned about this being negative. But if the absolute value of these x's get to be too much on that side or too much on that side, it's going to make this number here too big, and it's going to make me have a negative radicand. So I want you to think about that, and make sure you understand how I came to that conclusion. There's other ways to solve this little inequality here, but that's a way that I think you can kind of think through and begin to understand intuitively. So my domain of this function is negative 2 radical 2 to 2 radical 2. And it includes both of those numbers. That's why there are brackets, because I can have 0 as my radicand. I just can't have a negative number. So that's the domain of the problem. The next thing I'm going to do is I'm going to find the derivative of my function. And before I start doing that, I'm going to change it into rational exponents. So I have y equals x times 8 minus x squared to the 1/2 power. And I have a product here. So I'm going to have to use the product rule. The product rule, as you may remember, uv plus uv, and I have the derivative of u and then the derivative of v. So let's do it. So I'm going to have y prime is equal to, well, the derivative of my u, derivative of x is 1, times v, which is 8 minus x squared to the 1/2, plus u, which is my x, times the derivative of v, which is 1/2 8 minus x squared to the negative 1/2. That's my outer function. And now I need to do the derivative of my inside function, which would be times negative 2x. That's the derivative of that piece right there. So let's simplify a little bit. I have y prime is equal to 8 minus x squared to the 1/2 power plus, well, I have a couple things going on here. Well, actually, instead of being a plus, it's going to be a minus, because I have a minus sign right there that is being multiplied times everything. So I'm going to change that into a minus. And I'm going to have an x times an x, so that's going to be x squared. And the 2 is going to be canceled out by the 1/2. So I have minus x squared times 8 minus x squared to the negative 1/2 power. Now, one of the things I've kind of stumbled across in doing a number of these problems is that if I have, especially when I'm using the product of the quotient rule, if I can factor out something that has a negative exponent, it makes my life a lot easier, and I'll show you why. So what I'm going to do here is I'm going to factor out an 8 minus x squared to the negative 1/2. And if I do that, factor that out, that means it's times, well, if I have 8 minus x squared here, it's the same base, and I want to end up with a positive 1/2, that means this is going to be times 8 minus x squared to the first power, because add the exponents, 1 plus negative 1/2 is a positive 1/2. And since I've already, let's put it like this here, and since I've already factored it out over here, it's just going to be minus x squared. So what I've accomplished by factoring out the negative exponent is now I know exactly what's going to be in the denominator, if there's going to be a denominator, and I knew there was going to be a denominator because I had a negative exponent. So in the denominator is going to be 8 minus x squared to the 1/2, because it was to the negative 1/2 in the numerator. And my numerator now becomes, well, I have these nice things, I even have like terms, becomes 8 minus 2x squared. So by factoring out this negative exponent factor, I was able to really quickly get to a point where I could have a nice, relatively easily understood a derivative. Now I'd like to find what is the domain of the derivative. I'll call that domain prime, even though that's probably totally unorthodox. And my numerator is a polynomial. I don't need to worry about that. I do have a denominator with a variable in it, and I do have that's the same thing as a radical sign with an even index. But way up above, I already found the domain for 8 minus x squared, the square root of 8 minus x squared. So it's going to be the same negative 2 radical 2, comma, 2 radical 2. The only difference is that this is going to have parentheses, because it cannot include negative 2 radical 2 or positive 2 radical 2, because that would then make my denominator equal to 0. So my domain of the derivative is a little bit more restricted, and that's not surprising, because although I don't know exactly what this function is going to look like, I know that it has a limited domain. So let's say it looks like this. I don't know what it looks like. Let me just see here. I mean, if here is negative 2 radical 2, and here is positive 2 radical 2, I know that my function, again, I don't know what it's going to look like, but it's going to start and end at those 2 points. I'm going to have endpoints. which is something I'll have to pay careful attention to. But since they're endpoints, they do not have a derivative. A derivative, if you recall, has to have a derivative on both sides of the point. And endpoints, by definition, only have one side. They have left or right derivatives, but they don't have a derivative, which means you would have a derivative on the left side and the right side. So it's not surprising that the domain of our derivative is open-ended. The other thing that this means, and I'm going to come back to this later on, is that our denominator here, because we have this restricted domain, is always going to be a positive number. We've restricted our domain in order to keep it positive because we can't have a square root of a negative number. So this is always going to be a positive number in the denominator. That's going to make it easier for us to do our first derivative test. So remember, we're looking to find extrema, local and absolute extrema. We've already determined we have endpoints, and endpoints are pretty much always some kind of an extrema. But I want to find where I might have other extrema. I need to set my derivative equal to 0. So I want y prime to be equal to 0. And since y prime is 8 minus 2x squared over 8 minus x squared to the 1/2, I want to find out where that's going to be equal to 0. And when I have a fraction, so if I have 0 divided by 7, we know it's equal to 0. Or if I have 0 divided by 100, we know it's equal to 0. If the numerator is 0, then the whole expression is going to be equal to 0, with the possible exception is if the denominator is also equal to 0, but we're not going to worry about that right now. So what I need to find out is where is 8 minus 2x squared, my numerator here, where is that equal to 0? Well, I can do that. I'm going to have 8 is equal to 2x squared. I just moved the 2x squared to the other side. I have x squared is equal to 4. So I find that x is equal to plus or minus 2. So where x is equal to plus or minus 2, that is where I'm going to have a critical point, which is also going to be stationary because it's equal to 0. The derivative is equal to 0. Well, now I need to find what are my y values there, because I would like to have the actual point. So let's go back up to my original function, which is x times the square root of 8 minus x squared. So let's rewrite that. I have x times the square root of 8 minus x squared. That's my y, my actual function. And what are the values when I have x equals 2 and positive 2 and negative 2? Well, that would be, so y of 2 is equal to 2 times the square root of 8 minus 2 squared. So that is equal to 2 times the square root, times the square root of 4. So it's equal to 2 times 2, which is equal to 4. So one of my critical points is the point 2, 4. What about the other critical point? Let's do y. Let's do y of negative 2, since I have plus or minus 2 right here. So y of negative 2 would equal negative 2 times the square root of 8 minus negative 2 squared. Well, that's equal to negative 2 times the square root of 4, which is equal to negative 4. So my second critical point is going to be the point negative 2, negative 4. Those are going to be my two critical points. And while I'm at it, I may as well find the values of my endpoints, the y values of my endpoints. So what is y of negative 2 radical 2? Well, that's going to be negative 2 radical 2 times the square root of 8 minus 2 radical 2 squared, well, that's equal to negative 2 radical 2 times the square root of 8 minus, well, 2 radical 2 squared is 4 times 2. Oh, wait a minute. That's 8. 8 minus 8 is 0. So the point is going to be, the answer to this is going to be 0. So I am going to have a critical point, or I should say an end point, at negative 2 radical 2, 0. And if this were to be positive 2 radical 2, it's really not going to make any difference, because positive 2 radical 2 squared, that should have been a negative sign there, but that's okay. Positive 2 radical 2 squared is also 8, so this is still going to be 8 minus 8. It's still going to be equal to 0. So I'm going to have another endpoint at 2 radical 2, comma, 0. Well, this is starting to get kind of interesting, and I'm going to draw my number line. So I know that I'm going to have several intervals here. Well, first of all, negative 2 radical 2 and 2 radical 2. Well, radical 2 is approximately equal to 1.4. And if I go 2 times 1.4, it's 2.8. The main thing I'm concerned about is if I'm placing it on a number line, I know that it's going to be bigger than negative 2 or positive 2. That's going to be bigger, absolutely. So let's say over here is going to be negative 2 radical 2. And over here is going to be positive 2 radical 2. And those are going to be my endpoints. In fact, I even know that they have a 0 value. So I know that I'm going to have points right there. So my intervals are going to be determined by my critical points. So I'm going to have one at 2, 4. So let's put it up here. Here's the point 2, comma 4. And I'm going to have another one at negative 2, negative 4. Negative 2, negative 4. And let's kind of draw my intervals in here. So I have 3 intervals going on here. Well, let's test a point in this interval over here. And let's test the point negative 3. Now we're testing it in the first derivative. So one thing that I can do is I can put my derivative into the calculator like I've just done. And I'm going to go second quick. And now I'm going to go, I'll clear that. And I'm going to go alpha F4. And I want to test my Y1, which is where it was. I want to test it for negative 3. So I put negative 3. And it turns out, I got an error. I can't do negative 3. Do you know why I can't do negative 3? Because the domain of my function only goes, only goes here, from negative 2 radical 2 to positive 2 radical 2. So that was a mistake, wasn't it? And I know that my endpoints are right here, so I have to actually test a number between negative 2 radical 2 and 2. So how negative 2? So how about if I test something like, well, alpha F4 Y1, I'm going to test negative 2.1. Oops, I got to make it alpha F4, enter parentheses, negative 2.1. It's a negative number. So my slope is going to be negative in this very first interval right here. Does that surprise me? Of course it doesn't surprise me. Because if I have an endpoint right here, and I know that the next point I have where it can change signs is down here, I can't go up and then down to there. If I did that, that would mean I would have had to have another critical point here. And I don't have another critical point there. So there was really no question that my first part of this graph was going to go down. And since it's a critical point, Let's just test the number in here. Let's test 0. So if we test 0 in our derivative, I'm going to get, I'll pull up the calculator again. I'm going to go alpha f4, y1, and I'm going to test it for 0. I get 2.82. Okay, a positive number. So I now know that in this interval, my slope is going to be up, which again doesn't surprise me, because I have to get from this point right here to this point right here. And the only way to do that is to go up. And I can't change directions in the middle between this interval and that interval right here, these two intervals, because otherwise I need another critical point. I don't have another critical point. And one other thing I want to point out here is that at 0, here's my original function right here. What is the value of y going to be at 0? Well, I have an x right there. My value of y is going to be 0 at 0. So I actually can tell I have another point that's going to be plotted right here. And this graph is going to be going up until it hits that point right there. And at that point right there, what's it going to do? Well, my next point is right down here. I know that it's going to have to go down. But we can test it. We can look at the calculator, we can test it, and I'm going to go alpha f4, y1, and I'm going to test it for the point 2.1, positive 2.1. And again, I get a negative number. So it looks to me like on this graph, I'm going to have, these are my critical points right here, at the point -2, -2 radical 2, this point right here, it looks to me like I have a local minimum, a local maximum. Because everything from that point is starting to go down. And at this point right here, -2, -4, I have an absolute minimum. Absolute minimum. There is no point on this graph that gets any lower. And my direction, my slope has changed from negative to positive, which means I have a minimum, and it happens to be an absolute minimum. At this point right here, 2, 4, it looks to me like I have an absolute maximum. There is no point on this graph that's any higher than that. And at this point right here, it looks to me like I have a local minimum. So we've used the first derivative test pretty effectively. If you want to stop now, you can. I want to point out one other thing about this function. My function again is x times the square root of 8 minus x squared. So let's just write it down here. F of x equals x times the square root of 8 minus x squared. And one thing that helps me in graphing is to determine whether a function is even, meaning it reflects across the x-axis, or if it is odd, which means it reflects across the origin. So even functions, let's go even functions, f of x is equal to f of negative x. Well, let's see if that's true. So here's my f of x. What is f of negative x? Well, that would equal negative x times the square root of 8 minus negative x squared. And if I simplify that, that's going to equal negative x times the square root of 8 minus x squared. Well, this is not the same as that. So it's not even. But is it odd? Odd functions are where f of negative x, which we just found, is equal to negative f of x. Well, what is negative f of x? If f of x is equal to x times the square root of 8 minus x squared, negative f of x, I just stick a negative sign in front of it. And sure enough, this is equal to that. They're the same things. This is an odd function. So when I came up here and I was graphing it, I know that everything is reflecting across the origin. Odd functions always include the point 0, 0. And when I found that I had this point 2, 4, so that is x, comma, f of x, the fact that it's odd also tells me that it would have negative x, comma, negative f of x. And that's this point right here. So I could have told that it was an odd function from the beginning, save myself a little bit of point-making hassle. So that's a ton of stuff with this problem. It's a good problem.